All right, Yusi, you're next.
Hi, Professor.
Hi, welcome. Okay, yes, you should be able now to share your screen with us, please.
Okay. Can you see my screen?
Yes, we can. Yes, it's
okay.
visible. Just take us directly to the model phase, please. Just don't go to the earlier
So
phases.
I split my analysis up into 3 stages. The first stage is just normal models. So naive Bayes, logistic regression.
By the way, show us, did you do any, you took the original data set as is? You didn't make any transformation to the data?
The what, sorry?
The data set that you pass into the models.
Yeah.
Is the original data set?
Yeah, yeah. The
no changes.
No, I did. So the EDA stuff is above. You said to skip past it.
Okay, I'm sorry. Yeah, but what kind of change did you make there? A quick one.
This is the same analysis that I submitted for project number 1. So I did label encoding and I dropped NA columns.
Okay, no, this is fine. This is fine. But I'm saying, did you introduce any new feature? You drop some of them? You normalize your data?
No.
Standardize? Okay, that's what I wanted to know. Okay.
Okay.
All right. So go to the models. You're taking the default values.
I did normal modeling for all of them for first. So I get these results and I've plotted the confusion matrices for these. So we see that the naive Bayes is the most variant, but the others are more consistent with each other. And then I also compare the metrics of these against each other. So the accuracy, precision, recall, and F1. And in terms of recall, because that's the defining metric that we're using, the naive Bayes is the best classifier. So the this next stage of analysis is using the SMOTE technique. And so again, I redo that for all 4 models and then comparing those, these are the confusion matrices for the SMOTE models.
Okay.
And then again, comparing the metrics, we find that once again, in terms of recall, the naive Bayes classifier is the best. So the next thing was predictions using hyperparameter tuning and only for the random forest and XGBoost.
Okay.
So the first thing that I do is I estimate some parameters for random forest. I use the randomized search CV to feed that into the model. I get the metrics, and then from the randomized search CV, the best parameters that it generated, I feed it back into the, I do this again, but this time I use the grid search CV parameter search space to see if that gives different results. I do the same thing for XGBoost, and I have summarized the results for this. So
overall, the hyperparameter tuning did it pay off? It was worth doing it?
No, I actually got the results. So I'm just showing that to you. So the results were actually the same for both randomized search and grid search. There was absolutely no difference. I don't know, maybe I could have added more parameters, or maybe I could have added a more broader choice. But I think that's something to look into later. But yeah, in terms of recall for random forest and XGBoost, there wasn't too much of a difference, but the random forest did better.
Okay.
And then I compare, just for random forest and XGBoost, I compare the 3 stages of analysis. So no SMOTE, SMOTE, and hyperparameter tuning. And I found out that the random forest model and the XGBoost model, they both do better using just the SMOTE technique and no hyperparameter tuning.
That's expected. But I'm sorry, this is no SMOTE. I will expect for both random forest and XGBoost with SMOTE application to jump up to 80%.
Yeah, I didn't have much time to really delve into the mechanics of hyperparameter tuning. Although I did do a lot of reading to learn more about it, but I think given a bit more time, I would definitely love to learn more about hyperparameter, because it's a very manual
process. For everyone.
Yeah,
yes,
for sure.
Yes.
And so finally, to summarize everything, I put everything into a single graph. So looking at the accuracy, precision, recall, and F1 score for the first 2 stages. So that's, normal versus SMOTE.
Nice.
And also the same graph that I just showed.
This is good summary. Yeah, good.
And so here I have concluded that, so if we look at just the first stage normal predictions, the naive Bayes is the best. If we look at the predictions using SMOTE, also naive Bayes is best. With hyperparameter tuning, they were both very similar to each other in terms of recall, but the random forest did better.
Okay.
And then overall, this is my breakdown of the results based on recall. So I would go for the naive Bayes estimator, probably using SMOTE.
Okay.
Purely.
All right, good. Good effort. Nice. No, this is a good summary, Ayushi. All right, good. Great work. Great work.
Thanks.
All right, thank you. Thank you. Thank you. Let's proceed.